All right, my friends, I hope at the very least you kind of found out what was weird about example three. And what's weird about it is that we cannot center it at zero. We just can't. So if you were to think about the graph of natural log of 1 is 0, natural log of e is 1, natural log of 1 over e would be -1, and etc. But you end up with a vertical asymptote at 0. So this function is just not defined at 0. So that means that we're not going to be able to use a Maclaurin polynomial for it. And so we'll have to go to the idea of a Taylor polynomial, but centered somewhere other than 0. And for this one, it didn't say where to center it. You kind of got to pick. But I think most people would choose to center it at 1. If that didn't occur to you, then you might love it. Anyway, at least love 1 more than any other number you could possibly use that is in the domain of natural log. So how on earth are we going to center, these things at a number that isn't 0? Well, really, we're going to do the same stuff that we've been doing, making sure that it has a y coordinate, first derivative, second derivative, third derivative, fourth derivative, all the derivatives, etc., in common with natural log. It's just that we won't be doing it at 0. We'll be doing it, 1 unit to the right of 0. So I want you to think about how would you shift something to the right 1 unit, So before we do example 3, let's actually go to the main idea here. So you'll have a new definition for when things are not centered at 0. And this is actually going to be the most important definition. We'll talk about why in a little bit. So if f has n derivatives at x equals c, then, and we'll write this out in a second, so p sub n of x equaling, and we'll fill this in, this will be called the nth Taylor polynomial for f centered at x equals c. Now, as far as writing it out goes, what I'm going to do is kind of like use a little trick here. So, and don't copy all this. I'll let you know when I get to the part that you'd need to copy. But, what if c was 0? Let's say I change c out for a 0. Well, that would be what we've been using so far, right? So you do f of 0 for the first term plus f prime of 0 times x. So I'm going to leave a little extra gap here for some room. And then you'd have plus the next term would be, what would the next term be? F double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial. And then you keep going like that until you get down to the derivative that you need evaluated at 0 times x to the nth power over n factorial. So that's what you do if your c value, where you're centering it, was 0. Well, the only difference between this and centering it at a different number is just shifting this graph the appropriate number of units. So, let's say you want to center it at x equals c, where c is positive. Well, you'd need to shift it to the right c units. So how do you shift a function to the right c units? You'd replace x with x minus c. So instead of x, you'd have x minus c. So every single x would be replaced with x minus c. Like x cubed would say x minus c cubed. Yeah, so I'll just go through and replace all the x's with x minus c's. But then also, you'd need to make sure that you have all your derivatives making sense. So instead of f of 0, you'd have f of c, right? Because you'd need the y coordinate to match at that value. And instead of f prime of 0, you'd have f prime of c. So all the zeros basically get replaced with C's. This is easier to do with a whiteboard. I just need you to know that. Okay, and then I just have to replace this one, I guess. Okay. So hopefully that makes sense, everybody. If you center it at something other than 0, you just have to shift it appropriately. So to the right or to the left. And so if C was a positive number, we'd have x minus C instead of x. And then instead of all the zeros for function values and derivative values, you'd be evaluating things at C. So do take a little bit of time and copy this down and do your best to memorize this one as we go. This is the one that I'll have you make a flashcard for. Actually, don't have you make a flashcard for the Maclaurin one, which seems a little silly because we actually do the Maclaurin one a little bit more than this one. But notice that if you just replaced all the C's with zeros, you would have the Maclaurin series. So that's why I think it makes sense to just memorize this one. You get a little more bang for your buck with this one. So, all right, my friends. Now let's go ahead and show how to use this beast to get to finish example 3 out. And so we'll center it at x equals 1. So this is how you do a 4th degree Taylor polynomial for f of x equaling natural log of x centered at x equals 1. I think it's important for me to say where I'm centering it at because the directions didn't say I had to. And if you chose to center it at something else, then, you're not especially wrong. Okay, so let's get started. So the procedure is very, very similar. You're going to need f prime. You're going to need f double prime, f triple prime. Whoops. And then I think just for fun, let's do the 4th derivative as well. Let's see, what did it say? Yeah, 4th. Okay. Not just for fun, because we actually need it. Okay, so we have all the way up to the 4th derivative. Now let's evaluate each one at x equals 1. So starting with f of 1 would be 0. F prime of 1 would be 1. F double prime of 1 would be negative 1. F triple prime of 1 would be 2. And the 4th derivative evaluated at 1 looks like it would be negative 6. Okay. So once we've got that, now we can say natural log of x is approximately equal to, please don't say exactly equal to, and so we're going to do f of 1. Actually, I think I'm going to write it out first. F of 1 plus f prime of 1 times x minus 1, because things are shifted to the right 1 unit, right? Plus f double prime of 1 times x minus 1 squared over 2 factorial plus f triple prime of 1 times x minus 1 cubed over 3 factorial plus, and they just asked for the 4th degree, so we'll just go that far. So that's the plan. Now we just put the right numbers in. So natural log of x would simplify down to be f of 1 was 0, which I think I'll go ahead and just write it. F prime of 1 was 1, so you just have x minus 1 for this piece. And then f double prime of 1 was negative 1. F triple prime of 1 was 2. The 4th derivative of f evaluated at 1 was negative 6. Whoops. There we go. And then the last step would be to just simplify it down a little bit more. I think I'll write it like, yeah. Notice the 2 and 3 factorial would cancel and you'd just be left with the 3 in the denominator. Same thing with the 6 and the 4 factorial. They would cancel and you'd just be left with a 4 in the denominator. There we go, my friends. Oops. And that would be the 4th degree Taylor polynomial expansion for natural log of x, centered at x equaling +1. All right, my friends, I hope this makes sense. I hope you do okay with the problem set, and I hope you'll ask me questions for the parts that don't make sense. Take care, everybody.